Hey there, it's Shannon MATHCHICK Myers, and today we'll be looking at this problem here where we need to find a basis B for the domain of T such that the matrix for T relative to B is diagonal. So we're given this linear transformation that goes from R2 to R2. T at x and y is equal to 2x plus 2y, comma x plus y. So for this one, E1 would be 1, 0. E2 would be 0, 1. And then if we look at the linear transformation, T at E1 is equal to T at 1, 0, which would be 2, 1. And T at E2 would be T at 0, 1, which would be 2, 1. So the standard matrix for the linear transformation A is going to be writing the first one, 2, 1 as a column, and the second one as a column. All right, so now we need to find the eigenvalues. And so if we take a look at lambda I2, right, minus A, that will be equal to lambda minus 2, -2, -1, lambda minus 1. And then to find the eigenvalues, we need to find the determinant, sorry, it's been a long day, of this and set it equal to 0. And so we'll get lambda minus 2 times lambda minus 1 minus 2 equals 0. Multiplying it out, we'll have lambda squared. I think that'll be minus 3 lambda plus 2 minus 2 equals 0. So we'll have lambda squared minus 3 lambda is 0. And then factoring, we'll have lambda times lambda minus 3 is equal to 0. So lambda 1 is 0, and lambda 2 is 3. And now finding eigenvalues, or sorry, eigenvectors corresponding to the eigenvalues. So for, let's look at lambda 1 equal to 0. That makes lambda I2 minus A look like this one. We'll have -2, -2, -1, -1. That's just plugging in 0 for lambda. And then our REF format of this one will have, just in case you're not familiar with how to do it on the calculator or something, I'll just do it on here. It's pretty easy to row reduce. So we go to second matrix, edit, and I'll just edit matrix A. We have a 2 by 2, and then we have -2, -2, and then -1, -1. And then we quit out of there. We go back into our matrix. Math, we want our REF. Back into matrix. And we want matrix A. Enter. That's going to give us 1, 1, 0, 0. Cool so far? So if we think about our x1 vector would be made up of x and y, right? Yep. Well, with this one you have x plus y is 0, and so x is negative y. Let y equal to t, then x will be negative t. So that will equal to negative t, and then if I factor out a t, I'll just have negative 1, 1. Cool so far? All right, and then for lambda 2 equal to 3, we'll have 3 minus 2 is 1. We'll still have that negative 2, negative 1, and then 3 minus 1 is 2. And then getting the RREF, we can just go, and it'll be a lot quicker. Second matrix, edit, A. All right, and then second quit, and now we can just go second entry to get this command, and our RREF will be 1, negative 2, 0, 0. So that means that x minus 2y equals 0, x equals 2y. Again, if we let y equal t, then x would equal to 2t. So vector x2 would be x and y, which are 2t and t, which is equal to t times 2, 1. Cool so far? Awesome. Now, when you find a basis for that, we can say that our first column would just be negative 1, 1. And then our second column would be 2, 1. And so B will equal to negative 1, 1 and 2, 1. So now we need to find the linear transformation evaluated at these vectors relative to the matrix B. So if I plug in negative 1, 1 to the original linear transformation, I would get negative 2 plus 2, and then negative 1 plus 1, so I would get 0, 0. And that's relative to B. And also remember that you can write this as a linear combination, right? So C1 times negative 1, 1 plus C2 times 2, 1 would be equal to 0, 0, which would give us negative C1 plus 2C2 is 0, and C1 plus C2 is 0. And if I added those, I would get 3C2 is 0. So C2 is 0. And if C2 is 0, then C1 will also be 0. Now, if I take a look at T at 2, 1, I'm plugging in 2 for x and 1 for y. So I would have 4 plus 2 is 6, and 2 plus 1 is 3. So I would get 6, 3. And then I still want to find that relative to b. So I would have C1 times negative 1, 1 plus C2 times 2, 1 would equal now to 6, 3. So we would have negative C1 plus 2C2 equals 6, and C1 plus C2 is equal to 3. Solving the system, I would have 3C2 is equal to 9, and so C2 would be 3. And if C2 is 3, plugging it back in, then C1 would have to be 0. So it's kind of like that extra layer that you have to go for this one. So what does that mean? That means for the first one, you just get the same vector, right? Because you basically have 0 times negative 1, 1 plus 0 times 2, 1 is equal to 0. And so if you recall, the output you get is going to be these CIs. And so we could say that this is equal to 0, 0. And then for this one, we would have 0 times negative 1, 1 plus 3 times 2, 1 is equal to 6, 3. And so this result would end up giving us 0, 3, which would make the matrix of T relative to B A prime equals 0, 0, 0, 3. So that's just kind of checking, but I believe what we were trying to find here was this basis. Cool, cool? I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. And if you like what I'm doing, go ahead and subscribe to the channel, share the video, hit that like button, and I hope you have a wonderful day. Bye.